Hello everyone, Alejandro Rios here, and in this video tutorial we're going to discuss how can we electrify objects. I hope you like it, and let's begin. So how do electricity manifest? By removing electrons from the outer orbits of atoms, turning them into free electrons. What we do is that we have a material with neutral atoms. It has balanced charges in the atoms, and we have the material to pass through a process. During the process, it is going to release the electrons it has in the outer orbits of its atoms. Okay, so we're gonna get free electrons and we're going to have non-neutral atoms. In that manner, electricity manifests. In the present slide, we have a list of methods we can use to electrify objects. We can electrify objects by friction, conduction, induction, chemical action, electromagnetic induction, light, pressure, and temperature difference. We're going to explain each of these methods during the rest of this video tutorial. When we electrify objects by friction, we are applying an effect that is called the Triboelectric effect. In this case, what we do is we get two materials of different type. Let's say a glass rod and silk. We're going to rub the glass rod with the silk. What happens is that the glass rod will transfer electrons from the outer orbits of its atoms to the silk, and then the silk will get negative electric charge, and the glass rod will get positive electric charge. So by rubbing two objects of different material, we might get electricity, so to speak. One object will get positive charge and the other object will get negative charge. Charging by conductions involve the contact of a charged object with a neutral object. Let's say we have a neutral object with no charge, and then we have a rod with negative charge in contact with a neutral object. If the rod has negative charge, the excess of electrons in the rod will be transferred to the neutral object. When we separate the rod from the neutral object, we're going to have that the object that once was neutral now is charged with negative charge. Through the process of electrification by conduction, the neutral object will get the same type of charge of the object we use to charge it. In this case, in the example we showed, we're using a rod with negative charge, which means that the object that once was neutral will get negative charge. If we had used a rod with positive charge, then the object would have gotten negative charge at the end of the process. When we electrify objects by induction, we don't need to have the objects to get into contact with the object that is already electrified. For example, in position 1, in the diagram we have on the slide, we see two objects that are neutral objects. So in position 2, what we do is that we approach an object with negative charge. What happens is that for the object on the left, the side of the object that is close to the negative charged object will have positive charge, since its electrons are going to be repelled by the object with negative charge. So the object on the left will have electron deficiency, and the object on the right will absorb all the electrons repelled by the negative charge in the object that is already charged, right? So for the object on the right, we're having excess electrons, okay? They are repelled by the object that is negatively charged. So on position 3, what we do is that we separate the two objects that once were neutral, okay? And on position 4, we take away the negatively charged object, and we see that the object on the left gets positive charge and the object on the right gets negative charge. So in this way we can charge objects without having to get into contact with an object that is already charged. We may have electricity to manifest by chemical reactions, as happens in car batteries. What happens in a car battery is that inside of the battery take place a lot of chemical reactions that has one terminal of the battery to lose electrons and the other terminal to gain electrons. So since one of the terminal loses electrons, it gets positive charge, and the other one that gains the electrons gets negative charge. So through chemical actions, we might have the terminals of a system to get positive and negative charge. Another way to manifest electricity is through electromagnetic induction. In this process, what we have is a moving magnet close to a conductor. The effect of having a moving magnet close to a conductor is that one of the terminals of the conductor will show positive charge and the other terminal of the conductor will show negative charge. So in this way we can manifest electricity. By this process we call electromagnetic induction, just by moving a magnet close to a conductor. Another way to manifest electricity is through light, by a process we call photoelectric effect. What happens during this process? Light brings energy to the outermost electrons of materials. In the case of the diagram we have on the slide, we have a material that is a metal. So light brings energy to the outer electrons of the metal and they get energized. They get energized enough to be free from the atoms of the metal, and then they turn into free electrons. That's the idea behind the solar panels we see in modern installations. Another way to manifest electricity is through pressure, by a process called piezoelectric effect. For this effect, we have a material in normal state, and there's no way we can see on any area of the material, in any area of the structure of the material, that we have electron deficiency or excess electrons. But when the material is stretched or compressed, we're going to see a structure that is rearranged by stretching or compressing the material. So since we are rearranging the structure of the material by applying pressure, stretching or compressing, then we're going to see that the unbalanced charges of the structure of the material will be rearranged, and then the electricity will manifest. Finally, another way to have electricity to manifest is through temperature difference. In this case, what we do is that we take two wires of different metals that dissipate heat at a different rate, and we join them at one end, and we heat that joint. Okay, we heat the joint with a flame or with any device that produces heat, and we're going to find that for one metal it's going to lose electrons and the other one is going to gain electrons. So we're going to have one metal with a net positive charge, and we're going to have the other metal with net negative charge. So through this process, temperature difference, we might have electricity to manifest. We just take two metals of different types that dissipate heat at a different rate, we join them on one end, and we take the joint and we heat the joint. And we're going to see that one metal we're going to have positive charge and the other metal we're going to have negative charge. Well, thank you so much for watching this video presentation. I hope you have learned something useful, and see you next time. Bye bye.